Okay, we're doing exponential equation word problems today. This is the standard. Create exponential equations and use logarithms to solve mathematical applicable problems for which only one variable is unknown. Okay, this is our growth and decay formula. This is the simple one. Y equals AB to the x power. The A is your initial amount. B is your base, words like double, triple, half, 1/3, etc. X is the time, that might be days, seconds, minutes, years, etc. Okay, this is example number 1. A population of 20 rabbits is released into a wildlife region. The population triples each year for 5 years. What is the population after 5 years? Okay. The initial amount of rabbits is 20, that's your A. And the word triples is your base. So you have your initial population that you start with, it's tripling, and your time is 5 years. And you just plug all those into the appropriate place, put it in your calculator, and you get 4,860. All right, now we're going to move on. And the reason I didn't give any more examples than that is because you had this in 9th grade. So moving on to this equation here, y equals A times 1 plus or minus r to the t power. And if it's an increase, you plus, and if it's a decrease, you minus. A is still the initial amount. R this time is not words like double, triple, half. It is in a percent, and you have to change that percent to a decimal, and you do that by moving the decimal 2 places left, and time, of course, is whatever the situation calls for in the problem, whether it's days, years, months, it will tell you. Okay, a newly hatched channel catfish typically weighs about 0.3 grams. That's your initial amount, that's your A. During the first 42 days of life, that's going to be our time, its growth is approximately exponential, increasing about 10% each day. Find the weight after 42 days. So our initial amount, 0.3 times, and you have to change that 10% to a decimal. So the decimal is understood to be on the end, and then you go 2 places left, that's 0.1. So 1 plus 0.1, and then 42 days, your exponent is 42. You put that into your calculator, and you get 16.4 grams. And this is our last example. Let me move it down. It's a little bit longer problem. You bought a computer for $1,800. The computer depreciates. That means this one's going to have a minus sign. At the rate of 29% per year, how much is it worth after 2 years? Your initial amount was that $1,800. And you do 1 minus 0.29 to the second power. That gives you, it's worth after 2 years about $907.38. Now, this asks us to do something a little bit different. It gives us the Y. In approximately how many years will the computer be worth 200? So you have its worth, and you set up the problem like this to begin with. This is what it's worth. 200 equals our initial amount of $1,800. 1 minus 0.29, only you don't know the time. So you're trying to find the time. So the first thing we do with the equation is we move the 1,800 because this is multiplication. So we divide and we move it over here and we solve. And 200 over 1,800 is 1/9 equals 0.71 to the x power. Now, when we were rewriting exponents in terms of logarithms in the past, we put this part on the left and the answer on the right. So I did that over here. I turned it around so you could look at it and see our loop-de-loo. Remember me saying, here we go, loop-de-loo. Here we go, loop-de-lie, like that. So we take and we draw our little loop to rewrite it. So the logarithm of base 0.71 of 1/9 is equal to x. And now we just put this into the calculator, this part into the calculator, and evaluate it, and we get approximately 6.4 years. Thank you.